The definition of random sampling is credited to John Venn and C.S. Pierce, and in 1927 the first table of random digits was printed by Tippett. Around the same time, another statistician by name W.S. Gossett, he was working on various statistical methods. In fact, yesterday I introduced the student's t distribution. So, actually it is attributed to W.S. Gossett, who wrote a paper on probable error of mean in 1907, and here he introduced the student's t distribution. He wrote under the nickname student. One of the most profound influences on statistical theory and its development is by R.A. Fisher. He is known as father of modern statistics. He joined Rothamsted Experimental Station in the year 1919, and he worked for several years in this experimental station, and there they conducted experiments in agriculture. And through his experiments he started developing the basic theory of statistics called Foundations of Statistical Inference, and his papers became very famous. In the year 1922 he gave almost all the elementary concepts of estimation that we study today. For example, the concept of maximum likelihood estimation, the concept of unbiased estimation. In 1923 he introduced the topic analysis of variance, which led to the designs of experiments. In the meantime, Polish mathematician Jerzy Neyman and E.S. Pearson, who was son of the earlier mentioned Karl Pearson, they started developing the theory of testing of hypothesis from 1926 onwards. So, they published a series of papers where they gave the so called Neyman-Pearson lemma and its applications for testing various kinds of hypotheses. Around the same time, R.A. Fisher has given his theory of likelihood ratio tests. Fisher and Neyman are credited with giving confidence intervals. Around the same time, Neyman gave the development of stratified random sampling, etc. Around 1930s, the subject statistics started to develop in USA also. In fact, G.W. Snedeker is credited with introducing the subject in United States of America. So, in 1920s he was working in Iowa State College, and there on the agricultural farms he started using various statistical techniques. Slowly other statisticians like Oscar Kempthorne and W.G. Cochran also joined in, and slowly the subject of statistics started in USA. In 1939, Jerzy Neyman, Abraham Wald, etc. moved to USA, and the subject got a big boost in USA. Meanwhile, in the erstwhile USSR or Russia, A.N. Kolmogorov and many of his associates, they developed the rigorous theory of probability and stochastic processes. In fact, the modern probability theory as we study today is based on the foundations of Kolmogorov's axiomatic definition. The statistics in India also did not lag behind. In fact, with the starting of statistics in Europe, the subject started to develop in India also. Apart from the ancient references such as Kautilya's Arthashastra, which was written in 321 BC onwards, where he has given detailed description of how to collect data on or census on various aspects of the state. We see the records of various kinds of census and other data in Gupta period as well as the Mughal period, and these are recorded. The modern statistical methodology in India got a initiative by P.C. Mahalanobis. So, in 1920s he was a student in England, where he came under influence of Carl Pearson and he saw the Biometrica journal. After coming back to India, he started to regularly use the statistical tools for various kind of studies. He was first one to understand the importance of the subject statistics, and therefore with his efforts he initiated Indian Statistical Institute in 1931, the prominent journal 1933, and he collected a group of very talented people around him who later on contributed greatly to various aspects of statistical methodology. People such as R.C. Bose, who made great contributions to the subject of designs of experiment, S.N. Roy, C.R. Rao, who contributed greatly to multivariate analysis, designs of experiments, linear models, etc. And therefore, Indians are not lagging behind in the development of statistics. With the efforts of Mahalanobis, Central Statistical Organization was established in 1951 by the Government of India to collect the data on various aspects of the state. In 1950, National Sample Survey Organization was established to collect data on various socio-economic aspects of the life. After this historical development, now we look at that what is the data, what kind of data we have, and what is to be done with the data. So, first aspect is the collection of data. Now, collection of data refers to two types of things. We have the so called primary data and the secondary data. For example, I want to study the growth of a sector of economy, say services sector, in past 10 years, how the development, or you can say what are the revenues through the export of the softwares. Now, for this I myself don't have to go and ask the companies, say various companies which are situated in say Bangalore or in Pune or in Hyderabad, which the so called software cities, where these companies are there, they produce and then they have a record of how much earnings they have through exports. However, one himself or herself doesn't have to go and collect this data. This data may be available by the Economic Ministry or the Ministry of Economic Affairs or a export wing of the Ministry of Finance, and we can simply take the data from there for our inferences. This is called secondary data. That means the data has already been collected by a government agency or by a private agency, but it is already there, and the person who is going to use it simply borrows that data for doing statistical analysis. However, there may be various other kind of aspects where one needs to collect the data himself or herself. For example, if today I want to know the consumption pattern for a particular product, so that I want to know that whether a similar product will be successful in another area if we introduce, then maybe I will myself make a survey and collect the data on that. This is called primary data or primary data collection. So, in general we deal with two types of data sets, one is primary data, one is secondary data, and depending upon what kind of is your objective, what kind of data is already available, we go for either of them. Now, when we collect the data on certain aspect, then there are two types of collections. One is complete enumeration, that means we take the data on each unit of the population, or we adopt sampling. So, what is the difference between these two? For example, when I say we want to know the consumption patterns of certain product, say suppose I say I want to know about consumption of a certain South Indian dish which is being taken by people. Now, here it is impossible to know the consumption pattern for each individual of a locality, because we may not be able to go to each person and ask him. Rather, what we can do is we can look at the restaurants in the locality and we can go there and ask for the sales of that particular item. Now, this does not represent full data, rather it is a subset of the population. So, we call it sampling method. Whereas, for certain other things complete enumeration is done. For example, when votes are taken for certain preferences by the government for certain elections, then it is a complete enumeration. The government carries out census every 10 years, which gives the data on each individual of the entire country's population and various aspects of those people. For example, what are their incomes, what are their ages, and various other kind of information. So, what happens that in depending upon the kind of study that we are having, we will go for either complete enumeration or for sampling. By sampling, we mean that we take only a subset of the population. Now, in most of the practical studies, it is not possible to look at the complete enumeration, because complete enumeration may be too time consuming, too lengthy, and it may not fulfill the objectives because of the inaccuracy coming into, because of the implying of a large number of personnel and also the time taken for the complete enumeration. So, in most of the cases, it is a very practical thing to take a sample, or you can say a representative sample of the population and draw the conclusions based on that sample. Now, the sampling methodologies are also of two types. One is a subjective or purposive or judgmental sampling. For example, I can take a set of people and get their responses on a certain opinion. We may take their opinion for a certain thing and to suit our needs. For example, if we have introduced a new legislation, and now I want to know that how many people are happy with it. So, if I have the target group and such that they are happy with this one, we will take only their opinion. So, this type of sampling method is called subjective or purposive or judgmental, and it is not having any statistical base. It is used for certain purpose by various organizations, people, politicians, or any other type of people who want to get certain response based on their preferences. And second aspect is random sampling, where we take a sample which represents the whole population. That means each unit of the population has a certain probability of getting selected in the sample. So, in statistics we are concerned with random sampling. So, now if we have a data, whether it is through complete enumeration or through sampling, we need to analyze it. Now, before analysis, we have to firstly make a presentation of the data to make it suitable for statistical analysis. The first job of a statistician when he gets the data is to scrutinize the data, that is for possible inaccuracies which are too glaring. For example, if it is the heights of say school children and the heights are measured in say centimeters, so maybe all the heights are in the vicinity of say 50 centimeters, say a school going child in a primary school, and there is an entry which shows say 50 or say we are talking about inches, so 50 inches, and suppose there is an entry 150 inch. Now, what does 150 inch represent? It means a person who is of more than 12 feet height. So, obviously a school child cannot have this height. So, it will show an inaccuracy. For example, if we have kept the record of certain dates, and so we are recording the dates in terms of say day, month and a year, and there we suddenly show for a day the number is written as 45, obviously it cannot be correct. So, first of all, a statistician's job is to see the data carefully and point out actual, or you can say glaring inaccuracies which may be made due to wrongly typing or inputting the data, or various kind of things may be there, and come to and analyze that why this error is there. So, if it is a genuine error, it should be removed, or it may still be accurate. For example, in a set of students whose heights are in the vicinity of say 70 inches, and there is a person with height 80 inch, then maybe there is a genuine person who is very tall. Now, there are various types of data. So, one is the data which is collected over time or collected over space. For example, we keep that in a year, say 1991, the exports were say of the tune 10,000 crores. In the year 1992, the exports were say 10,500 crores. In the year 1993, the exports were say 10,300 crores. That means we are collecting the data or recording the data based on years or time. This is known as time series data. Another data of the similar nature is collected by area or space. For example, what is the population in the year say 2010 in countries. For example, what is the population in USA, what is the population in India, what is the population in Russia, what is the population in China, etc. So, this data which is collected according to the space, it is known as spatial data. So, these are known as non-frequency data because it is collected according to time or space or area, etc. The other kind of data is known as frequency data. For example, if we are recording the IQs of 15-year-olds of a town, the data on the agricultural production of a certain crop over a state, these kind of data are known as frequency data. So, in this particular discussion, we are concerned about the frequency data. Now, how to represent the data? The simplest, or you can say the most common way of presentation of the data is a textual representation of the data. For example, read a report in a Government of India Gazette or a Government of India economic report or a report on say agricultural area. So, the report reads something like this: the total geographical area of India is 329 million hectares. The statistical information regarding land utilization is available for 305 million hectares. No information is available for about 7% of the total geographical area, that means about 24 million hectares. 41 million hectare or 13% of the geographical area is barren land. That means agricultural production is not there in this land, and this land corresponds to something like mountains, deserts, rivers, canals, buildings, roads, railways, etc. That means effectively it cannot be used for any type of cultivation. 67 million hectare or 20% geographical area is under forests. 12 million or 4% area is pastures or grazing area for cattle. 19 million or 6% of the area consists of tree crops. That means the trees are there, they may give crops or may not give crops, but they are under the trees. 30 million hectare or 9% is fallow lands, and 136 million hectare or 41% is the net area which is sown under certain crops. So, basically we wanted to show how much is the area which is actually under the crops, and that is represented here, that is 41% of the area. Now, this type of information, or you can say data, one cannot use this kind of textual presentation if we have large masses of the data, when there are large number of variables and when there is a lot of information to be presented, then this kind of descriptive presentation is not very convenient. Of course, this is usually presented in the official reports or the presentations for the management, when the management tells to the company or to the shareholders what are the things, they simply give a textual report. The disadvantages, apart from that one cannot draw too much information, is all. Another drawback is also that one may give a selected or selective information to the persons. From the actual data there may be a lot of information, but the management may present only what is favorable, and they may hide certain facts which may not be very nice to know or nice to tell. So, the most popular form of presentation of the data is the tabular representation. So, in a table, so for example, we may say that the persons with, see, there may be certain farms which have agricultural production of a certain capacity. So, suppose the number is 15. Certain other agricultural farms, they have production between certain thing to certain thing, such number is say 300, and certain higher income, or you can say high productive fields, suppose there are 10 in number. So, a routine kind of table may look like this, which tells something about the values and the frequencies corresponding to that. We will see about these things more later on. One of the most popular forms of representation of the data is diagrammatic representation, where we make use of certain diagram to effectively tell the situation about that particular data. This type of presentation is extremely useful when you are making presentation in front of an audience, and through visual presentation they can immediately make out the change, or you can say various kind of information that can be drawn from the data. For example, we are looking at the volume of exports year wise from 1985 onwards up to year 1994. The volume of the exports in the in crores, and we are presenting using a line diagram. So, in 1985 the export was to the tune of say 12,000 crores. In the year 86 it became a little less, say 11,000 crores. In the year 1807 it became again to the tune of say 12,500 crores. In the year say 90 it became to the tune of say 30,000 crores. In the year 93 say it became to the tune of 50,000 crores. In the year 94 it became slightly less than that. Now, this gives a extremely clear position of the volume of the exports year wise, and you can clearly see a pattern that from the year 1986 to 93 there is clearly an increasing trend. One may even say that what kind of trend it is slightly parabolic, or you can say quadratic increase in the volume of the exports, and from 93 to 94 there is again a drop, and the government may try to analyze that why there is a drop. So, this line diagrams for the time data or for the spatial data give a very nice way of presenting, and one can easily compare the things. A similar kind of representation is by bar diagrams. Now, this bar diagrams, so through this example I will show, we want to know average per capita consumption per month by different populations. So, here we have two populations, that is rural or urban population. So, what is the per capita consumption? We want to have a comparative study for various cereals, say rice, wheat, jowar, bajra or maize. So, if we see per capita consumption per month of rice for rural people, it is 6.5 kg, and correspondingly if we see urban, then the consumption is around 5 kg. So, this tells clearly that the rice consumption by rural people is per capita is slightly more than the urban people. Similarly, if you see wheat consumption, you find that the urban per capita consumption is slightly higher than the rural per capita consumption. Whereas for other crops such as jowar, bajra or maize, the rural consumption per kg per head is much more than the urban consumption. Now, people may draw interesting conclusions from there, and then they may try to verify through other sources. So, one may say that per capita consumption for each of the cereals except say wheat is higher for the urban people, for the rural people. Now, what does it mean? Does it mean that the rural people have more income, or they simply eat more? So, one may like to investigate this phenomena. Similarly, for wheat you have more consumption for the urban people. So, that means either urban people have more access to the wheat, or they prominently eat wheat products. That is why, like bread which is normally available in the market. So, their consumption of the bread or wheat goes up. So, one may like to investigate this further. So, this bar diagram gives a very clear cut comparative study, and also this tells the relative consumption of various cereals. For example, rice consumption is maximum compared to wheat, then jowar, bajra and maize, and this also may tell that about the relative importance of the crops for growing, and therefore, the government can also decide the policies, the farmers can decide their policies about these things. Some of the very extremely simple type of representations are through pictorial diagrams, which may not be very useful, but sometimes they may be helpful. For example, in the year 1990, the volume of exports was nearly 30,000 crores. In the year 2000, it was nearly 40,000 crores. In the year 2010, it was nearly 50,000 crores. So, here each unit here represents a volume of 10,000 crores, but this type of representation has clear cut limitations, because you cannot use it for various purposes, mostly if you have to use fractional data, and also if the number of units cannot be represented in integer type of things. Another very useful pictorial representation is pie diagram. So, if a particular population is divided into various categories, then how much is the share of the each category we can represent nicely in a pie chart or a circle, and here we make the sectors of the circle. So, this particular diagram represents the investment proposal by the government in the 5-year plan to various sectors of the economy. So, here for example, the government will spend 20% on services, it will spend say 19% on transport and communication, say infrastructure, it will spend 7% on agricultural or related fields, it will spend 9% on rural development, the government will spend some 3% of its amount on special area developments, 10% on irrigation or flood control exercise, some 23% on energy, and some 2% on science and technology, etc. Some 7% investment will be in the area of industry, minerals, etc. So, this kind of pie chart gives a very clear representation, comparative expenditure by the government on various things, and it is extremely useful. In the next lecture, we will be concentrating on how to actually represent frequency distribution, how to classify the frequency distribution, and what basic measures of central tendency or the dispersion can be evaluated from there. So, in the next lecture, we will be taking up these.